In order to understand which types of composites are more ideal for structural applications for DoD platforms, we first have to understand what a composite is. By definition, a composite is a material which is comprised of two or more constituent materials which have different physical or chemical properties. Once these materials are combined, the resultant material has characteristics different from the individual component. The key is that the end characteristics and properties are suitable for the DoD application. These characteristics include, but are not limited to, high strength to weight ratio, operational environmental resistance, property database to support design activities, low life cycle costs compared to the traditional materials, and the economical, reliable manufacturing processes. The key elements with the material is both to have the structural integrity required, as well as to have the low cost and low weight that is desirable for a DoD platform application. With all the critical parameters and possible constituent material combinations, the key to successful application really relies on the experience in the design and manufacturing. This experience is critical in the selection of the material, as well as development of the design configuration to maximize the benefits of the composite over traditional materials. In considering why some composites are more suitable than others for structural applications, one must realize that there are both primary and secondary structural applications in DoD platforms. When you consider a primary structural application, it is one in which the compromise may directly impact vehicle operation and could result in a catastrophic consequences with failure of that article. While loss of a secondary structure can be tolerated with minimal consequences, providing the component doesn't get ingested by a more critical primary component such as an engine. While relatively low-cost composites that use chopped fibers, low to moderate resin matrix materials, and particular reinforcement can be used for secondary structural applications. Composites for primary structural applications typically consist of continuous fiber reinforcement in a moderate to high temperature, damage-tolerant, chemically resistant, and environmentally tolerant resin matrix. The matrices and the fibers are selected for the DoD platform applications. In both instances, the arrangements of the reinforcement in the resin of the composite permit structural properties to be tailored for maximum performance. A myriad of manufacturing processes exist for the fabrication of composite materials, which are largely dependent upon the type of composite material and the configuration of the structure. Techniques include, but are not limited to, vacuum autoclave processing, press forming, resin transfer molding, pultrusion, and in situ automated tape placement. Some of these processes consist of significant hand labor, while others look to go to more of a fully automated process. The variety of these manufacturing processes provide flexibility for the designer to best match the process with the composite material, as well as the design to minimize processing costs while maximizing the structural properties of the resultant composite. Automated tape placement systems have been developed to minimize labor required to form composite structures. And then in the case of thermoplastic composites, the in situ automated tape placement process has applied localized heating and pressure to consolidate the composite as the material is being applied to the tool, thereby eliminating the need for post-processing required by a thermoset. This is typically called out-of-autoclave processing and is significant in reducing costs of the overall composite fabrication process. As ground systems reach performance limitations, opportunities are ripe for the application of composites to enhance performance and lower weight and life cycle costs. Examples of specific areas of application for DoD platforms include drive shafts, structural panels, access doors, and hatches, as well as struts, various structure, floors, rotor blades, and electronic enclosures, as well as control tubes.